We're asked to expand this logarithm, and it looks fairly complicated. It's not too bad as long as we go through each step individually. So let's go through that right now. This one is a natural log, but the same rules apply for this one as they do other logarithms, no matter what their bases are. Okay, so the first one that we're going to apply here is basically states that if these terms here, a times b, if it's multiplication, we can rewrite this as two separate logarithms, or more than that in this case, that we have up here. These two are just two logarithms. Log base k, a plus b. This addition sign is going to be key whenever we're expanding it. Let's kind of look at an example. This is log base 2 of 3 times p. So if we rewrite this, it will be two logarithms, log base 2, 3 plus log base 2 of p. So let's do that up here. If I do that, this is all multiplication, 4 times k squared times the square root of m. So I'm going to have three different components. This is going to be the natural log of 4 plus natural log of k squared plus natural log of square root of m. Now, and that was, the addition comes from right here, that basically states that if this is multiplication, we can just use an addition. Now we look over here and I've got the square root of m. The square root of m, we've got to understand what that is as an exponent. I can rewrite that one as an exponent. Square root of m is equal to m to the 1/2. That's our fractional exponent. If this were the cube root of m, it would be m to the 1/3. Okay, so I'm going to rewrite this one with the fractional exponent now. Okay, and this 1/2, these two are equivalent here. I wrote this one as an exponent here only because of our next step. And our next step states that if we have an exponent here, the way that we get rid of that one, or the way that we expand it, I should say, is to move it out into the front. Let's look at an example here. I have log base 6, a to the 8th. I take that 8 and I move it way out in front, and it should look like this. Okay, this 8 came from the exponent, we just moved it out in front. This one does not have any exponents other than 1, so we don't need to worry about it. This one, I've got to take this k squared, I've got to move that 2 out in front. And this one has a 1/2, so that one I've got to move that 1/2 out in front. So if I write my answer, it will look like this. The natural log of 4 plus 2, and the 2 came from right here, that exponent, of k, plus 1/2 the natural log of m. And that 1/2 came from here. And again, 1/2 as an exponent is the same as the square root of something.